Hey everybody, we're going to do a recording over the last three practice problems within 8.1. So we're going to go over slides 15, 16, 17, kind of go over how to get them done, what are the right answers, proper steps, everything from beginning to end for each one of those three. So very first thing that we're going to get started with is going to be taking a look at the actual problem itself. So whenever we start with our problem, the first thing we're going to want to do is break down the problem the most that we possibly can. So we're going to go ahead, we're going to break down these two into our factors. So we have an x minus 1, x minus 1, x plus 1, x minus 1. So we're going to rewrite this as x squared minus 2x plus 1 as x minus 1 times x minus 1 over x minus 1, x plus 1. Now we can easily see here that x minus 1 and x minus 1 cancel out. We are left with x minus 1 over x plus 1. This right here is our simplified equation. Okay, and that's very important because that's what we're going to be using throughout this entire problem. Now, since we were breaking down the equation as a whole, one thing we could easily figure out was our domain. So our domain comes out of our denominator. So we're going to go ahead, x plus 1 and x minus 1 are both equal to 0, and we're going to figure out what x cannot be. In this case, x such that x does not equal negative 1 and 1. Remember, here we're just setting each one equal to 0, and from there we are figuring out what that x cannot be. So that is our first step, is figuring out our domain and figuring out our simplified equation. Let's take a look at our second step. Our step 2 is going to be our vertical asymptote and or any holes. Now, let's start off with the holes. In order for you to know whether there's a hole or not, you have to figure out, is there anything that has been canceled off within our equation when we were trying to get to our simplified equation? In this case, because we were looking at x minus 1 canceling out, our hole would be x minus 1, which is equal to 0, which means x is equal to 1. So our hole is 1 comma something. Now keep in mind, this is going to be a point. Okay, so how do we figure out what the y is going to be? We are going to plug it into our simplified equation. So we're going to go ahead. Right, we're going to put in our 1 into our simplified equation. So 1 minus 1 over 1 plus 1, 0 over 2, which is equal to 0. So this right here would be 0. And we figured out the whole of our vertical asymptote and whole step 2. Now let's take a look at our vertical asymptote. Vertical asymptote, that is going to be where the denominator of our simplified equation, so that means this part right here, x plus 1, is equal to 0. So we're going to go ahead, x plus 1 is equal to 0, which means x is equal to negative 1. We're going to go ahead, put that right in there, x is equal to -1. Let's take a look at step 3. Our step 3, we're going to be taking a look at our horizontal asymptote and our slant asymptote. Now, with our slant asymptote and horizontal asymptote, it's either one or the other. So you cannot have both. So the main thing that we're going to take a look at is going to be the degree of both the numerator and the denominator. Now in this case, let's go back to our original problem. Notice the largest degree is going to be a 2 and 2. So both of our degrees are the same. So the degree of our numerator is equal to the degree of our denominator. Whenever that happens, that means that you are going to have to look at the ratio of the coefficients. So let's look back at our equation. Notice the coefficient is a 1 over 1. So our coefficient is 1 over 1, which means that y is equal to 1, and that is going to be for our horizontal asymptote. Now, because of that, we already know that our slant asymptote is going to be none, because it could either be one or the other. It cannot be both. So we've taken a look at number 2, which was our vertical asymptote and our hole. We've taken a look at number 3, which is our horizontal and slant asymptote. Our step 4 is going to be if it crosses. So what you're going to do is you're going to take a look at your horizontal asymptote. In this case, it is 1. And you're going to equal that to our simplified equation. So we're going to say one is equal to x minus 1 over x plus 1. Now you're going to multiply both sides by x plus 1 to get rid of it on the denominator side. This will give you x plus 1 is equal to x minus 1. Now notice, as we start working this equation, what happens? Our x's cancel out. Now, anytime that the variables cancel, it will not cross. Okay? It will not cross. I highly suggest that you write that down somewhere. It will not cross. Now, if you end up with some type of value, meaning x is equal to something, anything, any type of number, then it will cross. So if n is equal to a negative number, 0, or a positive number, it will cross. If the variables cancel, it will not cross. Let's take a look at our next step. Our next step here is going to be our y-intercept. So our y-intercept is going to happen whenever x is equal to 0. So we're going to plug this in to our simplified equation. Remember, it was right here, or much higher up within the page. And we're going to put 0 minus 1 over 0 plus 1. So we have negative 1 over 1, which is negative 1. So our y-intercept is going to be 0, comma, negative 1. Let's take a look at our x-intercept. X-intercept is whenever y is equal to 0. Now, something to keep in mind is that if we take a look at what we had solved before, we had said that we have a hole at 1, 0. Notice y is equal to 0, which means that we do not have an x-intercept. So that would be none. Keep in mind, there's a hole there, which means there is no value when y is equal to 0. Once we've gone through and figured our x and y intercept, that is going to be the time that you're going to do the range. Now here you're going to have to analyze everything that you've already put down to determine what it is that our range is. Now, you have to remember that the main things we're going to take a look at is what number it cannot equal. So we're going to take a look at our horizontal asymptote, where it says y is equal to 1. And we're also going to say 0, because remember, it's going to be a hole. So there are two places where we do not have on the y side of our graph something occurring. So because of those two things, we know that y such that y cannot equal 0 and 1. And that is our last step. Highly suggest, highly suggest, watch the video over, watch it a couple times, start becoming familiar with the entire process of it, which ones to do in what order, and kind of go from there. Okay, we're going to go on to our next practice problem, which is going to be slide 16, and then kind of go from there. Actually, before we go to slide 16, let's finish off with slide 15. We're going to do actually end behavior. So our end behavior. The limit of f of x approaches as x approaches infinity, and the limit of f of x approaches something as x approaches negative infinity. Now, the most important thing that you need to know is that you are always going to be approaching your horizontal asymptote. So what is your horizontal asymptote? Well, we had said it before. Our horizontal asymptote is 1. So the answer here is going to be 1. Let's take a look at slide 16. So we go ahead, start from the beginning. We want to find that simplified answer. We want to find that domain. In this case, we're going to break down our denominator to x minus 9 and x plus 3. Now, in this case, we can easily see that nothing is being canceled out and that our simplified equation is going to be x over x minus 9, x plus 3. Now you can leave it as x squared minus 6x minus 27, and that's going to help you later on when we start taking a look at our horizontal asymptote and our slants when figuring out the degree of our numerators and denominators. But until then, let's figure out our domain. We know from our factored form that x cannot equal -3 and 9. Remember, we set it equal to 0 and solve for that answer. Next step, we already know that there is no hole. How do we know that there isn't a hole? We know that we did not cancel anything when we were getting into that simplified equation. Our next step is our vertical asymptote. We know that that is going to be where our domain is, meaning we know that x is going to be equal to -3 and x is equal to 9. Let's take a look at our next step, step 3. So here we're looking at our horizontal asymptote or our slant asymptote. First thing is, we already see that our denominator is greater than our numerator as far as the degree. Anytime that happens, we know that y is equal to 0 is our horizontal asymptote. Now keep in mind, every single time that we have a horizontal asymptote, we will not have a slant asymptote. So this is none. We do have to determine whether or not it is going to cross. So we are going to find our horizontal asymptote, which is 0, and we're going to set it equal to our simplified equation, which is x over x minus 9, x plus 3. And we're going to multiply both sides of that equation by our denominator. So x minus 9, x plus 3. And we're going to multiply both sides, which is going to leave us with 0 is equal to x. Now, we already figured out that x is equal to 0. That is the first part of our cross. So there is a cross. We now have to figure out what is the second portion of that point. In order for you to do that, you're going to have to get that 0 and plug it into the equation. So we have 0 over 0 minus 9 and 0 plus 3. That means 0 over -9 and 3, which is 0 over -27, which is 0. So our point is going to cross at 0, 0. We're going to go ahead and figure out our next step, which is our y-intercept. Now we know that our y-intercept is whenever x is equal to 0. So where do we have x equaling 0? Well, that is where that cross asymptote occurs, which means our y-intercept is going to be 0, 0. Our x-intercept is going to be 0, 0. We're going to take a look at our last part, which is going to be our range. Now in this case, we don't have a slant asymptote. There are no holes, which means that y for our range, such that y is all real numbers. Our final step here is going to be the end behavior. So we have the limit of f of x approaching a number as x approaches infinity, and the limit of f of x as x approaches negative infinity is going to give us a number. Remember what we said before, that is mainly based off of our horizontal asymptote. So we take a look at our horizontal asymptote, it is 0, and in this case, our missing numbers are 0. So here we're going to hop on over to our last example, which is slide 17. We're going to do the exact same thing that we've done each and every time. We're going to work with simplifying our equation and figuring out our domain. That is our first step every single time. So we're going to go ahead and break this down into x minus 1 and x minus 1. Notice in this case, we would have x to the third over x minus 1, x minus 1. Our denominator is x minus 1, which means if x minus 1 is equal to 0, x is equal to 1. So our domain is x such that x cannot equal 1. Now we take a look at our simplified answer. Notice we did not cancel out any type of factors or numbers or variables. So in this case, do we have any holes? No, we don't. We're going to go ahead. We're going to take a look at our second step, which is going to be our vertical asymptote. Now, our vertical asymptote, remember, we are taking a look at our simplified answer, and we are looking at the domain. Here, our vertical asymptote is x minus 1 equals 0, which means x is equal to 1. Our step 3 is going to be our horizontal and our slant asymptote. So we start off with taking a look at the degree of our problem. Now, anytime that we have a difference of 1 with the numerator being greater than the denominator, notice here we have x to the third, and in the denominator we have x squared, we will have a slant asymptote. Remember, you can either have horizontal or slant. The fact that we are saying that we already are telling that we're going to have a slant asymptote means that our horizontal asymptote is going to be none. Now, how do we work with our slant asymptote? In order to do the slant asymptote, this will have to be done using long division. And what we're going to do is that we are going to divide x to the third power divided by x squared minus 2x plus 1. Now, at that point, we will need to use every single term, and we just cannot use x to the third. So we would have to fill it in with x to the third plus 0x squared plus 0x plus 0. And our entire goal is to fit that x to the second power into x to the third. So we go ahead, we would have to multiply by x. Multiply that out, x to the third minus 2x plus 2x squared plus 1x. Now keep in mind, we are always going to subtract. And as we subtract, we're going to be left with 2x squared minus x plus 0. We go ahead, work it a little bit further. Positive 2 is going to make sure that everything cancels out as far as our first term. 2x squared minus 4x plus 2. Keep in mind we are subtracting that as well. And we're left with 3x minus 2. Now this right here is our remainder. Our remainder does not matter to us. What matters most is the quotient at the very top. And our answer for our slant asymptote will always be given in the form of y is equal to mx plus b, which means our answer here is y is equal to x plus 2. Now, our next question is going to be, where does it cross? Which is going to be number 4. Now, here, remember, we are going to get our slant asymptote, which is x plus 2, and we're going to set it equal to our simplified equation, which is x to the third over x squared minus 2x plus 1. And we're going to multiply both sides by that x squared minus 2x plus 1 minus 2x plus 1. That will cancel the denominator. We're going to work on the left-hand side. This will give us x times our entire parentheses will give us x to the third minus 2x squared plus x. And then we're going to multiply the 2 against everything in the parentheses, which is positive 2x squared minus 4x plus 2 is equal to x to the third. We're going to go ahead, combine our like terms. Notice over here we have a negative 2x squared and a positive 2x squared, which cancel out. We're left with x to the third power plus x, and a negative 4x is a negative 3x plus 2 is equal to x to the third power. We're going to go ahead and subtract x to the third power from both sides. We are left with negative 3x plus 2 is equal to 0, and we're going to go ahead and solve for x. So negative 3x is equal to negative 2. X is equal to 2/3. Now keep in mind, we actually ended up with negative 2 over negative 3, but that does turn into a positive 2/3. Now, since we did end up with a number as part of our cross, that means there is a y. In order to figure out the y, we're going to have to go ahead and plug it into our horizontal asymptote. So, sorry, not horizontal asymptote, our slant asymptote. So we're going to go ahead and we're going to plug in y is equal to 2 over 3 plus 2. Now, we're going to rewrite that positive 2 as a fraction so that we can blend it together with the 2/3. We're going to end up with y is equal to 2/3 plus 6 over 3. So y is equal to 8 over 3. And that right there is where it crosses. At 2 thirds, 8 thirds. Our next steps are going to be our y-intercept and our x-intercept. So we're going to go ahead, we're going to take a look, and we're going to plug in our 0 in for our y-intercept. Now keep in mind, whenever we have a y-intercept, that means we are plugging in 0 in for x. We are plugging that 0 in. We'll do that right over here. 0 to the third power over 0 squared minus 2 times 0 plus 1 is equal to 0 over 1, which is 0. So this is going to give us our y-intercept at 0, 0, which means our x-intercept is also 0, 0. So that leads us to our range. Now, we are not going to do the range or the end behavior anytime that we have a slant asymptote. So because of that, we can just cancel that off, and we are actually done with this problem. Highly suggest that at some given point, take a look over these 3 slides. They will be extremely beneficial as far as you doing well within your 8.1 quiz. So highly suggest take a look over it, become comfortable, and use this video whenever you need to.